In this last part of our application, we are going to see how to create the user menu. First, notice that I wrapped the code for the user menu in a try except block, just to cover any keyboard interrupt exceptions that might be generated by the user when pressing Ctrl+C. Okay, back here. Next, notice that I use the while loop because we want the user to be able to go back and forth inside the menu using continuous statements without quitting or restarting the application. The first thing to do is print out the first screen of this menu, which asks the user to enter an option in order to access some functions of the application. So in the main screen, the user can choose to run the application either for DHCP client simulation or for DHCP client releasing. Each option should be shown on a different line. That's why I used the \n. And also the user has to have the chance to exit the program. That's why I added the last option, E, exit program. Whichever option does the user choose, it will be stored in a variable, user option sim, and it will be used to decide the next step. For decision making, we will use, of course, an if block. So notice that if the user types in S at the prompt, then some piece of code will be executed. If he types in R, then another piece of code, the one related to DHCP releases, will be executed. Finally, if the user types in anything else, the program prints this message and then quits. Okay, now let's study the case when the first option is chosen. So, if the user option sim variable takes the value of S, then the program will guide the user to the DHCP client simulation functionality. The first thing, I chose to notify the user that all the leases will be exported to a file in the current directory called dhcpleases.txt. If you feel the need to tell or warn the user about some important stuff while running the application, don't be afraid to just insert a print statement and a short message. Next, we ask the user to input the number of DHCP clients to simulate and the interface on which to start sending the discover packets. This is a bit redundant because we entered the same interface earlier to enable promiscuous mode, but I thought it wouldn't hurt to be as explicit as possible. Of course, we store the number of clients to simulate and the interface in different variables for later use, packet number and packet interface. Now you can think of the number of DHCP clients to simulate as the number of times the generate DHCP sequence function is executed, since each execution of this function means creating a single DHCP transaction. To run this function for as many times as the user chooses, we will use a for loop and the range function. Of course, the packet number value, this one over here, should be converted to an integer because it is initially a string returned by the raw input function. Another thing I should mention is that when a function returns multiple values, as our function does over here, it actually creates a tuple of those values and returns it. Then you can unpack that tuple or access its element using indexes. The first value returned by our function is the allGivenLeases variable, which is a list. We can access that variable this way by simply pointing to the first element in the tuple returned by the function, the one with index 0 in our case. So for each iteration, for each DHCP client we want to simulate, the function will be executed and the list of leased IP addresses will be populated. As a test, let's uncomment this print statement right here, run the application and simulate 3 DHCP clients. Okay, so Python dhcpsim.py eth1 s for simulate 3 DHCP clients eth1. Okay, so this is the list of IP addresses given by the server that we get. Okay, great. Now if something goes wrong while running the function and the DHCP transaction fails, then no leases will be returned and the program will raise an index error, since this index right here will refer to an inexistent value. In this case, the DHCP server or the network connection is to blame and should be fixed. The application will print these messages right here and terminate its execution. Now let me comment this back, and let's take care of the file in which the leases are stored. We will open the file for writing using the open function. The function will overwrite it if the file already exists, otherwise it will create a new one. Now for the next operations, let's first see these lists over here. So let me uncomment this print statement. And let's ask the server for 5 leases. So let's save the application. Let's run the application again. ETH1, S, 5 clients, ETH1 again. Okay, so these are the 5 IP addresses we just got from the server. Next, we have the list of servers that each address was obtained from. In our case, having a single server, the IP address is the same. And finally, we have the list of client MAC addresses that we have generated earlier. This one over here. Basically, with each DHCP transaction, our program added an element to each list. Now back to the code. Remember the enumerate function? It helps us iterate over a sequence using both the index and the value of an element as iterating variables. We need the index to match the values in these 3 lists by transaction. So for each index and IP address in the list of IP addresses, right here, we will add a line in the file containing the IP addresses received from the server, the corresponding server IP in the second list, so this one over here for the first transaction, and the corresponding client MAC address in the third list, based on index, of course. Now back to the code. We could have used the write method to write the lines in this file, but I wanted to show you another way to do it, using print and 2 angle brackets, followed by the file object name, DHCP leases in our case. After the file object name, you should type a comma, and after that comma, you enter the string to be printed to the file. In our case, we will concatenate the IP address, a comma, the server IP located at that same index in the second list, then another comma, and finally the client MAC address also matched by the index. Finally, as always, remember to close the file. After the lines are written to the file, we want to take the user back to the menu, and that's why I've added a continue statement at the end. Now let's discuss how the program behaves if the user chooses the second option, R for release. This is covered by an elif statement, of course. So if the user option sim variable takes the value of R, then we want the program to enter a submenu where the user has to decide whether he wants to release a single address or all the addresses received from the server. That's why I used another while loop over here. Inside this while loop, the first thing to do is to show the user the options he has to choose from in this submenu. So release a single address, release all addresses, or exit to the previous screen. Next, using the row input function, we capture the user input and store it in a new variable, user option release. To make further decisions, we will use another if block, of course. So if the user enters S to release a single address, then the next thing would be to type in the address to be released and store that string inside a variable. And this is the role of user option address variable right here. Of course, we still have in memory the 3 lists which we populated when simulating the DHCP clients. So we will use them here to generate the DHCP release parameters we need to execute the generate DHCP release function, which takes 3 arguments: the IP to be released, the client MAC address, and the server ID. Now moving forward, based on the IP address entered by the user, we should check that it is a member of the all list IPs list. Actually, we are checking if the IP address has been indeed leased by the server to a client before trying to release it. This is done using this if statement right here. So if this condition is true, then we should identify the location of that IP address in the list based on its index using the indexList method. After finding its index, then we can call the generate DHCP release function and pass it the IP address we just found, the corresponding MAC address, and the corresponding server ID based on that same index. In the else block, in case the IP address typed by the user is not found in the list, then we should print a message to the user and then continue back up to the while loop and display the release menu again. Now notice I wrapped this code here in a try except block. This is because whenever we want to release some addresses, the preconditions are first, the all list IPs list should already exist in memory, meaning we should have simulated some clients prior to trying to release them. And the second precondition, the IP address we enter at the prompt should exist in the list. Because we are using these lists, which are stored in memory at runtime, we shouldn't quit the application before trying to release any addresses. Otherwise, we could encounter a name error exception or an index error exception, because the list has not been yet generated or the IP address has not been received from the server when trying to release it. The client simulation and the client IP address releasing should be performed in the same program session, and that's what we are covering in this except block. If any of these exceptions occur, then the program prints these messages and then quits. Next, if the user chooses A to release all the IP addresses, then the procedure is almost the same, only this time we use a for loop to iterate over all the IP addresses in the list and run the generate DHCP release function for each address and its corresponding server ID and MAC address. Finally, as a cleanup action, we can also delete all the leases which were stored in the DHCP leases file by simply using the open function to open a file for writing. Remember that this actually deletes the file contents, and then immediately close the file to save it, all in a single line of code. Also, I've added a continue statement to redirect the user back to the menu after the DHCP release and file cleaning have been completed. Next, let's make a few tests on our application.